We're looking at something called as balanced and unbalanced force. The definition of balanced force is this. If the vector sum of two or more forces acting on an object is 0, such a force are called as balanced force. That is, a net force is equal to 0. So F net is equal to 0 Newton. So let's have a look at how this 0 Newton force looks. So what is the setup? I have a toy car that is attached to a thread, and thread is attached to a set of weight. So these two weights, when hung down, would pull the cart, and in this case it's pulling with the same force. That is, if I happen to represent this with an FBD, free body diagram, there are two forces acting, one acting to the left and another acting to the right. So this is a force to the right, and this is equal to 0.4 Newton. How I got this value? That is something that we'll understand later. And there is one more force to the left, and that too is 0.4 Newton. And this scenario is what? Is a balanced force scenario. Of course, there are two more forces. One being the gravity and one being the normal force. That is something that I'm not talking about, but to be frank, there are two more forces. Gravity, and this is your normal force. So all this force put together, they are balanced force, because an object just kept with this force will not move. Any external force, any extra force will make it move in any possible direction. And you guys saw that as well. I had an extra force which made it move forward, backward, right? I could have made it go up also. That is left to the external force. One more example is a single book on a table. The free body diagram would look like this. You will have the gravitational pull and the normal force acting on the book. So that would be normal, and that would be gravity. So this is a balanced force, reason being the net force is 0, right? The vector force is 0 on this. So as simple as this. And next is unbalanced force. So you can you can think about it. It's quite simple. It's a vector sum wherein two or more forces acting on an object will yield a non-zero force. So basically, please understand this. It can be a positive or a negative value force. Okay. So now let's have a look at an example. So what we saw over here was the same toy car was attached to a heavier weight on the left while lighter weight on the right. So what happened? The car as a whole moved to the left. So the FBD would look like this. You have a small force of 0.2 Newton. A small force, but a bit, actually double of this. So I have to double the length. Double the length would be somewhere over here, I guess. This would be 0.4 Newton. This is the total force. Actually, there are two more forces, one being your gravity and one being your normal. So these two are cancelling each other, but the right and the left, they're not cancelling each other. So F net over here, if I take left and up as positive, so then F net force would be 0.4 minus 0.2, which is 0.2 Newton would be your magnitude. With the direction it would be 0.2 Newton left, right? So this is an example for unbalanced force. Now, a person walking, very simple scenario. So what is the free body diagram of this? We have an object moving to the right. In this case, a person. So the net force or the forces have to be a larger to the left. And stopping this is your frictional force. So the FBD for this would be frictional force, that is to the left. And we have the push force, that is to the right. So this is basically your free body diagram for this particular scenario. That is, of course, other than this, you have your gravitational pull and also normal force. These two are neglected for your syllabus, so I'm not talking about it. So don't think too much about this, because again, it will make it complicated for you guys. It'll be a bit confusing. So any point of time, left and right, just handle left and right. Right? So these are your unbalanced forces and these are your balanced force. Very important to understand the entire topic. So you need to understand what is balanced and unbalanced force. Actually, let me expose you guys to this. It's important for you guys to keep this in mind as well.